This is Ham College, episode 89, for May 31st, 2022. Ham College is brought to you by Icom. Field Day, Ham Radio's most popular event of the year, is just around the corner. Be a Field Day leader with Icom. Hi, welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we're glad to be back with you tonight. We're still studying for the Amateur Extra exam, and I don't know, we're probably just slightly over halfway through the extra pool. You guys are going to need to study if you're going to take that exam. I mean, sure, we're going to give you all the answers here, but that's only part of the challenge.
Yeah, you're going to have to do your part too. It's hopefully we're helping though.
Yeah, hopefully. You know, we're both extras, so if we can do it,
you can do it.
Yep. Well, there you go. What did we talk about last time, Dean?
I do remember we talked about AND gates and OR gates, so programmable logic stuff. There must have been some other stuff in there too.
Like digital ICs?
Yeah, that.
And family of digital IC gates.
This stuff on the cheat sheet right here.
Programmable logic devices, PLDs. And this month, we're going to talk about something completely different. What's that going to be?
That's a good question. We're going to talk about, probably going to butcher the word, toroidal and solenoidal inductors, permeability. This is tongue twister night. Core material selecting, winding, transformers, and piezoelectric devices.
Okay.
Wow. Can't say that 3 times real fast.
You could try, but you probably couldn't.
So. I can't even say it 1 time slow, not all of it.
Well, what do you say we jump right on in? Let's see. Last time, I think you probably took the receiving hit up front.
I think I did.
So I'll do that this time. Well,
Seems like a setup.
Well, I haven't planned any of this out, so I don't know where the questions are going to fall.
Okay.
So we'll just have to see.
Why should core saturation of an impedance matching transformer be avoided? A. Harmonics and distortion could result.
B. Magnetic flux would increase with frequency.
C. RF susceptance would increase.
Or D. Temporary changes of the core permeability could result.
I was just thinking about this a couple of weeks ago.
You know, it's one of those things that's on my mind.
Guess we're going to clear it up.
Yeah. Why should core saturation of an impedance matching transformer be avoided? Well, the magnetic flux would increase with frequency. That's not it. RF susceptance would increase. No, we're maybe not even talking about an RF transformer here. Temporary changes of the core permeability could result. No, I think the permeability is kind of fixed. So that leaves harmonics and distortion could result. That's going to be my answer. I'm going to say A. What do you think, Dean?
The chat room's kind of mixed a little bit between A and B. I don't see anything about flux capacitors, so I'm going to go with A with you.
Okay. And it is A.
Should have been. Maybe we'll get that flux capacitor question sometime.
And the reason I kind of knew this, I do a lot of audio engineering. It's been one of my hobbies for a long time, that and recording music and such. And I know that a lot of the equipment built today is old school stuff. They're recreating some of the classic designs of microphone preamps, compressors and limiters and such. And they are very selective about the transformers that they use in these, to where they wouldn't go to, well, not that there's one anymore, but they wouldn't go to Radio Shack and buy a transformer to use in one of these.
Yeah, that's why we don't have a Radio Shack anymore.
Must be. They would use, some higher dollar transformers, and some of those have a much higher value to them now. Some of those companies are still in business, and it's because of the character to the sound that those transformers will give it.
Yeah, some of those transformers are pretty pricey, man, because we were talking about a project one time. I was looking for one, and they were kind of high.
I've got an ATC transformer. It's a little sort of a square one that I pulled out of some piece of gear back in the mid 80s. And I see that thing selling now on eBay for like $70.
Wow.
I don't know what they were new, but anyhow, so, not that this is audio related, but it's the same thing, impedance matching transformers and harmonics and distortion, which is, in that application, that's a good thing.
Mm-hmm.
Because they want the harmonics and distortion a lot of times to create a certain sound. But we're not really so much talking about sound here. That's just an effect of it if you oversaturate it. So, question for you. What is the equivalent?
This was a setup. I smell a rat.
It feels like it,
I
doesn't
smell a rat.
What is the equivalent circuit of a quartz crystal? Is it A, motional capacitance, motional inductance, and loss resistance in series, all in parallel with a shunt capacitor representing electrode and stray capacitances? This sounds a little like a turbo entabulator, doesn't it?
I think I need to go to the party that's going on the street over. B, motional capacitance, motional inductance, loss resistance, and a capacitor representing electrode and stray capacitance all in parallel.
C, motional capacitance, motional inductance, loss resistance, and a capacitor representing electrode and stray capacitance all in series.
Lord have mercy. D, motional inductance and loss resistance in series, paralleled with motional capacitance and a capacitor representing electrode and stray capacitance. What is the equivalent circuit of a quartz crystal? I think I just used a quartz crystal. I honestly have absolutely no idea, and I'm so tempted to look at the chat, but I'm not going to.
May not help you.
Motional capacitance, motional inductance. This is the series. I really don't know. It doesn't matter. Pick a number. Pick a letter.
A, B, C, or D?
I'll go with B because it ain't the first one.
Okay. Well, they're a little mixed in the chat room
What are
there.
they saying? Oh, yeah, that's all over the place, too. E.
Yeah.
I'll go with Mike. It's E.
I already gave a G. So
that's a good one, too.
Yeah.
G's for good.
This is a tough one. I'll agree.
I have no idea. I try to reason it out, but I just don't really see it.
Okay, we're off to a good start tonight.
All right.
Well, you don't get one for that.
Maybe I should have took that first one.
Yeah.
I'm like, well, I'm not going to take the first one because I don't know.
Yeah.
Remember what you said about not having any reason for some of the logic? That's another one of those.
Okay. Well, you want me to do some explaining?
Yeah, please.
Here's our answer right here. It's motional capacitance, motional inductance, and loss resistance in series, all in parallel with a shunt capacitor representing electrode and stray capacitances. Motional means like variable. To have a resonant circuit, typically we've got an inductor and a capacitor because one's swinging positive and the other's swinging negative with reactance. And when you put them together, it's resonant at a particular frequency. And the resistance there that's in series with those two is very low resistance. That's good because all this together makes a real high Q circuit. If there was a bigger resistor, the Q would be broader. This thing wouldn't resonate right on a particular frequency and hang there like crystals do. The capacitance in parallel with it there, or the shunt capacitance, that's representing the electrodes or the leads to the crystal and any stray capacitances that are in there. So really it's just an RLC circuit. Make more sense now?
A little.
Yeah.
That's pretty tough.
I'm going to say that's the toughest one tonight.
Whoever decided to put this question on there is probably still laughing.
Yeah, could be.
I wouldn't doubt that one bit. Okay. Which of the following is an aspect of the piezoelectric effect? A. Mechanical deformation of material by the application of a voltage.
B. Mechanical deformation of material by the application of a magnetic field.
C. Generation of electrical energy in the presence of light.
Or D. Increased conductivity in the presence of light. Which of the following is an aspect of piezoelectric effect? Well, it has nothing to do with light, so you can rule out C and D. So that leaves A and B. And it has nothing to do with the magnetic field. So that only leaves A. It's mechanical deformation of material by the application of a voltage. I don't know. Makes sense to you?
Yeah, that's got to be A.
Okay. Chat room? Well, looks like they're all saying A there.
That's how a piezo buzzer works.
Yep. As a matter of fact, I just got a photo here. You want to explain it?
When you apply voltage, it vibrates.
Yeah, that is a piezoelectric element out of a buzzer.
Yeah.
And, it just so turns out these things are bidirectional.
So if you wire it up opposite polarity, it removes all the buzzing sound from the air.
This right here, if I could get it where you could see it, that's what we were just looking at, wasn't it?
Sure is.
This is not a buzzer.
What is it?
If you hooked a voltage to it, it probably would buzz. Piezoelectric effect is bidirectional. So, this could be used like a contact microphone. If you had it down on a desk or something and you were tapping around, it would pick that sound up. But this particular one right here goes in a set of electronic drums.
Oh, interesting.
And I got, I'm actually replacing some parts in mine. This little black object right here, this little cone, is like a spongy rubber. And the head of the drum, mine have mesh heads in it, but this sits up under and contacts the head of the drum. And the piezo element sits right up under it. So whenever you strike the head, this gets the pressure of it, it transfers that shock down into the piezo. It generates an electrical signal which goes out as a trigger. So this is a drum trigger right here. This is what it is, but it's also a buzzer. Could be.
Interesting.
It's the same device. Which materials are commonly used as a core in an inductor? Is it A, polystyrene and polyethylene?
B, ferrite and brass?
C, Teflon and Delrin?
Or D, cobalt and aluminum? Which materials are commonly used as a core in an inductor? I'm gonna go ahead and go straight for the throat there and go with B, ferrite and brass.
You didn't fool around on that one.
No, it's probably wrong, but I don't think so.
Well, that's what all the chat room's saying.
Well, then we'll all be wrong together.
I'm going to agree with you. And it is. Here you go.
All right.
I'll give you one.
Totally redeem myself.
Polystyrene and polyethylene are insulators.
Yeah, that wouldn't make a good one.
I wouldn't think so. Teflon and Delrin, I don't remember what Delrin is, but I think that's an insulator too.
Yeah, Teflon is.
Teflon definitely is. Cobalt and aluminum. Well, I just kind of, aluminum's doesn't have the right properties. I'm not sure about cobalt, but yeah, ferrite and brass.
Yeah, I know for sure ferrite, so I think brass.
And actually, a ferrite has a high permeability. Brass has a negative permeability. So between the two, they can come up with just the right combination to get the inductance or the permeability that they need in that inductor.
Oh.
So that's why, that's why you find ferrite and also brass typically on inductors that are adjustable, like in an old radio or something. The core, where the coil's wrapped around, that'll be ferrite, and the slug that goes down in it, brass.
Oh.
Because when you screw that brass down there, it changes the inductance.
Interesting.
Yeah, a good combination. I didn't really know that until I got to studying up on it, because I had to come up with some kind of explanation.
Yes, that's a good one. It is interesting.
Yeah.
Stuff you just don't really think about.
Well, yeah, it's,
unlike the what is a circuit that's good substitute for a crystal, quartz crystal.
True.
I mean, that's something you think about all the time.
No,
well, maybe not.
Maybe
all the
not.
Time. What is one reason for using ferrite cores rather than powdered iron in an inductor? A, ferrite toroids generally have lower initial permeability.
B, ferrite toroids generally have better temperature stability.
C, ferrite toroids generally require fewer turns to produce a given inductance value.
Or D, ferrite toroids are easier to use with surface mount technology. What is one reason for using ferrite cores rather than powdered iron in an inductor? Well, they've been using ferrite since way before we had surface mount technology, so I know it's not D. Let's see. Ferrite toroids generally have low initial permeability. No, you would want a higher permeability, or else you got to have a bigger one. Ferrite toroids generally have better temperature stability than powdered iron. No, I don't think so. I believe there's one that really just kind of jumps out and says, pick me, and that's C. Ferrite Toroids generally require fewer turns to produce a given inductance value. That makes sense.
Sounds like a plus.
Yeah. That's what they're all saying over in the chat room, and we know how smart they are.
Top notch.
Top notch. All right, and I think, let me see where we are. Oh, we got another one here.
Oh, we didn't run out?
We hadn't run out yet. We're getting close. But there's no more motional inductance or capacitance tonight. I don't think.
Emotional or emotional?
Either.
Either.
Yeah.
It could get kind of emotional there with one of them questions.
What core material property determines the inductance of an inductor? A, thermal impedance.
B, resistance.
C, reactivity.
Or D, permeability. Well, material determines the inductance of an inductor. Material property. I'm going to go with D, permeability, after the conversation we just had on the last one.
Yeah, I should have kept my mouth shut, shouldn't I?
No. No, you shouldn't.
Okay. Well, that's what they're all saying over in the chat room. I think you're on to something there. And you are. Permeability.
That was a pretty good gift right there.
Well, I mean, you wouldn't. I'm not sure what thermal impedance is. I don't know. Maybe insulation, like fiberglass, has a thermal impedance. I'm not sure what that even means. And no, it's not resistance. Reactivity, I could think maybe you'd go that way, but no, it's permeability. Permeability. I don't say that right, but I never have. Well, after that, we're almost halfway through.
Okay.
What do you say we take a break?
Go to the party next door?
Well, that, while the audience enjoys some classic entertainment.
Oh, sounds great.
As you may have noticed, in the past few years, high-frequency ham radio beam antennas have not only become more complex, but also far more narrow in beam width. Some claim to be as narrow as 4 to 5 degrees, with a front-to-back ratio of 30 dB or more. This in turn requires a more accurate rotor and pointing device, one that can swing a very heavy multiband Yagi from east to west in record-setting time, yet be able to stop on a dime without permitting any antenna motion, even in gale force winds. Well, down under in windy Perth, Australia, a company known as Twistantenna has been doing research aimed at producing a new antenna pointing system, one that not only minimizes power consumption, but is also capable of automatically synchronizing up to 360 cardinal grammeters for exact antenna orientation. And while it's taken a bit of time to contort, now it's here. Meet the maker of the Twistantenna Model 1-4-2012 contest and DX rotor system.
To be quite candid, the only really new principle involved is that instead of rotational power being generated by the relative motion of conductors and fluxes, in the turbo-entabulator contest and DX rotor system, motion is produced by the medial interaction of magneto-reluctance and capacitive durectance.
During the initial design phase, the concept was to use a base plate of free famulated amulite surmounted by a malleable logarithmic casing attached in such a way that the two spurving bearings ran in a direct line with the parametric fan. This meant offsetting the rotor from the tower by 36 to 40 inches. Not a good idea of installation in small city lots in crowded urban areas. Now, however, after several years of research and development, the final design stage consists of 6 hydroscopic Marzul vanes fitted to an amberfescent lunar wane shaft made of titanium alloy to prevent any side fumbling, and there's no need to offset it from the tower center line. The main traction winding is of the normal Lotus odaltoid type placed in a panoramic semi-bulloid slot of the stator. Every seventh conductor is connected by a non-reversible trimmy pipe to the differential girdle spring on the up end of the grammeters. Moreover, whenever fluorescent square motion is required, it may also be employed in conjunction with the drawn reciprocation dingle arm to reduce sinusoidal depleneration. In other words, when the rotor braking system is engaged, the antenna is locked in position and will not move unless you, or possibly your pet cat, hit the control box to move it. The twist antenna model 1-4-2012 turbo entabulator antenna pointing system has now reached a high level of development and is being successfully used in the operation of the fully functional automated DXCC logging station of Milford Turins in the United Kingdom. Best of all, the entabulator antenna pointing system is now available for less than $19.99 per tower installation kit wherever Twist Antenna products are sold. Be a Field Day leader. Field Day is ham radio's most popular event. On June 26th and 27th, more than 40,000 North American hams come together to operate remotely. Connect with nature. Connect with friends. With a powerful and high-quality Icom radio, easily cut through pileups to get that contesting edge. Our popular IC705 portable, IC7300, and IC7610 SDR transceivers are the clear choice for DXers and contesters across the globe. The IC705 is the perfect transceiver for hams who enjoy both the great indoors and outdoors on Field Day. Features and functionalities at the tips of your fingers in a portable package covering HF 6 meters, 2 meters, and 70 centimeters. And it weighs in at just under 2 pounds. 4.3-inch color touchscreen with live band scope and waterfall. 5 watts with BP 272, 10 watts with external 13.8 volt DC. Single sideband CW, AM, FM, as well as full D-Star functions. The IC7300 is a high-performance innovative HF transceiver with a compact design that will far exceed your expectations. This is a radio that changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real HF fun starts here. The IC7610 is the SDR every ham wants. This high-performance SDR has the ability to pick out faint signals in the presence of stronger adjacent signals. The Icom IC7610 is a direct sampling software-defined radio that has changed the world's definition of an SDR transceiver. RF direct sampling, 110 dB RMDR, independent dual receivers, and dual digicell. For more information on these and all the great Icom radios, visit icomamerica.com/amateur. What do you say we give away something?
Yeah, I found this. We'll give this away?
Why not?
Great shirt. Somebody would be glad to get it.
You've been trying to give that shirt away for I don't know how many years now.
Several?
Yeah,
it's a good one, though.
Yeah.
We've given a lot of them away.
Oh, we have given a lot of them away. As a matter of fact, I saw Jesse and the whole Icom crew last week at Hamvention.
Yeah?
Yeah.
Was he wearing his shirt?
No, they weren't wearing T-shirts. They had a little dressier shirt than that. I believe now. Don't hold me to that.
They usually wear them when they're setting up and tearing down.
Oh, yeah. Yep.
But I bet you saw a few walking around the Hamfest.
Oh, yeah. I did.
They looked pretty good, didn't they? They looked good when they showed up.
They did look
and
good.
I bet they looked just as good when they were headed back home.
And you remember those green Icom boonie hats that we got when the IC705 came out?
Yeah.
I wore mine because, that's pretty good Hamfest attire. Now, you got to admit, especially on an outdoor Hamfest like that, I thought I was going to get tackled and it was going to be stolen. There were people wanting those, man.
Really?
There aren't anymore.
Oh, wow.
They only were giving them out back.
Must be a COVID shortage.
Well, it was only when they
Yeah, I'm
introduced
just
that rig, but
Yeah.
But
Yeah,
yeah.
they're pretty cool hats. Better hang on to it. Might be collector item.
so if you wanted one of those, what would you need to do?
One of these?
One of those. If you wanted a chance to win one of
Oh,
those.
I thought you meant your hat.
No. You can't have my hat.
Well, but the shirt here is pretty nice too. All you gotta do is send an email to hamcollege@AmateurLogic.TV. That's it.
And
Maybe you give us a name. You don't even have to have a call sign. You don't have to be a ham. Some of our giveaways you need to be a licensed amateur to get some of the gear, but
not this.
this one's open for
Yep.
everybody. Send an email to hamcollege@AmateurLogic.TV, like I mentioned, and you can put a note in there if you want to. You don't have to, but if you send one, we enjoy reading them.
Mm-hmm.
So, also, if you happen to not be the one that wins this time, be sure and send your name back in for next month because we clear the queue out after the drawing's been made, so it starts over fresh.
And the drawing was made right before the show tonight, and I've already cleared the queue out, so
send them on this way.
send them on. I chose a random number,
Who's the random
and
winner?
the random winner this month, if I can read it here, Russ Clavitt.
Awesome.
And he actually, he put, 2 sentences. We don't always get that kind of response.
Nope.
He said, "Gents, thanks for Ham College. In part, it helped me pass my extra class this month. N1 HVX. Well, congratulations, Russ.
Awesome. Yeah, congrats. And remember we said earlier we hoped it was helping somebody? There you go.
Yep.
Another happy customer.
And you notice he said, thanks in part, or in part it helped me pass. You know, just watching us alone, I mean, yeah, it'll help you with the exam, but we don't guarantee you're going to pass. You're going to actually have to put in a little effort, a little study, like for us.
Exactly.
And you, too, could be an amateur extra. And double congratulations once on passing your exam. And
and they'll be in touch with you to get your size information and your shipping information for your shirt.
And once for being the best dressed ham at the next Ham Fest.
There you go.
Coming and going.
Coming and going.
All right, we got a few more questions here to go. Well, I think we got as many as we'd already done and maybe one more.
What is the current in the primary windings of a transformer called if no load is attached to the secondary? A, magnetizing current.
B, direct current.
C, excitation current.
Or D, stabilizing current. What is current in the primary winding of a transformer called if no load is attached to the secondary? Well, I don't think it would be called a stabilizing current, starting at the bottom. And excitation current? No, not really, because nothing's connected, so it's not exciting anything. Direct current? No, transformers don't pass DC, so you're probably not putting DC across the primary of a transformer. Wouldn't be any point in it anyway. So that leaves magnetizing current. And if you think about it, the primary winding of a transformer,
The electromagnet.
Yep, it's an electromagnet. If nothing's hooked to the secondary, then you're just sitting there creating a magnetic field or magnetic current.
It makes sense.
I think that's what it is. What's the chat room saying?
Several things.
Oh, okay. So we may not be right. Excitation current seems plausible, but it's not the answer. It's magnetizing current. So
It makes sense.
yeah, and you know, I go over these. I gotta get them put into the computer here,
Mm-hmm.
along with the answers. So some of them, well, I always look at it and try to get the right answers before I look and see what the answer is to mark it there in yellow.
Mm-hmm.
I was thinking excitation current on this one.
Really?
Yeah, and I noticed that came up
So
in the
there
chat
we
room.
go. We got an even score. We're going back to honesty.
But I didn't say it. And if I
You
was
didn't
looking at the
say it.
chat room, I mean that was a popular answer. In
It
there.
was.
Yep.
I mean, I could see how someone could think that was
Well,
it.
yeah. But it's not. So.
But if you think about it, it is exactly an electromagnet.
Well, yeah. Yeah, 'cause just don't think about secondary, and that's what you got.
Mm-hmm.
What is one reason for powdered iron cores rather than ferrite cores in an inductor?
Ooh.
A, powdered iron cores generally have greater initial permeability.
B, powdered iron cores generally maintain their characteristics at higher currents.
C, powdered iron cores generally require fewer turns to produce a given inductance.
D, powdered iron cores use smaller diameter wire for the same inductance. Okay, so let's go through this process of elimination here. The reason for using powdered iron cores rather than ferrite cores. A, powdered iron cores generally have greater initial permeability. Well, that's false because we established in a couple of questions back that ferrite cores do. B, powdered iron cores generally maintain their characteristics at higher currents. That seems plausible, so I'm going to leave that one in the pool here. C, powdered iron cores generally require fewer turns to produce a given inductance. Well, that's got to be false too because we established that a few other questions back too. And we got powdered iron cores use smaller diameter wire for the same inductance. And I don't think that that's right. I just don't think that that's right. So I'm thinking it's going to be B. Powdered iron cores generally maintain their characteristics at higher currents.
And that's the people brave enough in the chat room. That's what all of them are saying.
Brave enough?
Brave enough. Yeah, I'm going to agree with you. And it is.
Interesting. I probably say that a lot, but it is. Actually, I know I say it a lot, but it is interesting.
Yeah.
It's pretty cool stuff.
Yeah.
What devices are commonly used as VHF and UHF parasitic suppressors at the input and output terminals of a transistor HF amplifier? A, electrolytic capacitors.
B, Buttersworth filters.
C, ferrite beads.
Or D, steel core toroids. What devices are commonly used as VHF and UHF parasitic suppressors at the input and output terminals of a transistor HF amplifier? Well, I've actually seen a lot of, well, yeah, some. I shouldn't say a lot, but transistors and HF amplifiers, or HF amplifiers with transistors.
Mm-hmm.
And, electrolytic capacitors, those are going to be most effective down at lower frequencies. They're not so good for getting parasitics out of VHF and UHF. That's out of their range. Buttersworth filter, I don't recall seeing those used.
I've never even heard of that.
Yeah, I've heard of it. It's, but it's not used for parasitic suppression. ferrite beads or steel core toroids? Well, we know ferrite is better
Mm-hmm.
out of the two. So I'm going to say it's C, ferrite beads, just because I've seen it. Everyone in the chat room is saying
Well,
C.
that's what I would have picked also. So that might tell you you might want to change your answer. I'm just kidding. No, I think that's right.
And it is. And ferrite beads, I think probably most everyone watching this knows what they are, but here's a couple of examples here. You got that USB cable and it's got that lump right there near the end. That's ferrite bead.
Yep.
In the left lower corner there, those are snap-on ferrite beads. You see them over a lot of wires. That's actually what's inside the plastic on that cable there. And they come, in snap-ons like that or as, single pieces, but that's what a ferrite bead is.
I bought a whole bunch of those, like the bottom left one there at
Me
Dayton
too.
one year. I've used almost every one of them. There's probably 4 of them in my truck now.
Mm-hmm. And all of those are not created equal.
Right.
The core material they use affects, how they perform at different frequencies. And I always have to look it up because I can't remember which, it goes by numbers, which is good for VHF and UHF or HF or, I just look it up. What is the primary advantage of using a toroidal core instead of a solenoidal core and an inductor? A, toroidal cores confine most of the magnetic field inside the core material.
B, toroidal cores make it easier to couple the magnetic energy into other components.
C, toroidal cores exhibit greater hysteresis.
Or D, toroidal cores have lower Q characteristics. A, toroidal cores confine most of the magnetic field within the core material. Well, they make chokes out of them. That seems like a pretty good thing for that. I'm going to go with A, because I think that's why they work for chokes. A, toroidal cores confine most of the magnetic field within the core material. So that helps keep it from passing.
I think that makes sense, along with everyone else in the chat room.
For what that's worth.
Well, there you go. And if you think about it, you got the circular, the toroidal core there, and yeah, you could see how that would confine most of the magnetic field inside the core material.
Yeah.
Or if it was a solenoid, or a straight, wound inductor or core, you could see the end of that magnetism like a, electromagnet. I've got a couple of examples here. In the lower right-hand corner, toroidal inductors there. On the left-hand side, well, that's a toroidal transformer. I'm seeing more of that style of transformer today in audio gear at work in particular.
Really?
And in power supplies because they're more efficient than regular old iron cores that would typically be in a power transformer, and doesn't take as much area. So they can, they can take a single height rack unit and put the power supply in there, and they can still have high current and, not as big a transformer for the power supply.
Yeah, interesting.
Yeah.
Fun fact, I used to work for a company. We wrote software for one of our customers was in Canada. They made transformers, but they were big electrical transformers.
It wasn't Hammond.
No.
Yeah.
I don't want to say who they were, but it wasn't. Yeah. It was a cool place to see. Yeah. They had patented a thing to where they put all those plates together to form the wire around it and everything. It was a pretty amazing place.
What type of core material decreases inductance when inserted into a coil? A. Ceramic.
B, brass.
C. Ferrite.
D, powdered iron.
Seem familiar to you?
Should I go straight for the throat again?
I don't know. Yeah, maybe.
I'm going to go for B, brass.
You know,
And the only reason is because I have a pretty good memory for today. Tomorrow it'll be wiped clean when I get up out of the bed and I have to start over again, but this is fresh enough.
Sometimes it only takes like 30 seconds as demonstrated earlier tonight.
That is true.
Yeah, they're all saying B over in the chat room. There we go. All right, we still got a few more questions here.
All right, more fun to come.
Yep.
What is inductor saturation? A, the inductor windings are overcoupled.
B, the inductor's voltage rating is exceeded, causing a flashover.
Or C, the ability of the inductor's core to store magnetic energy has been exceeded.
Or D, adjacent inductors become overcoupled. What is inductor saturation? Well, just right off, I'm going to say you're passing so much current through there that the inductor is no longer changing. You've reached the point that it's not going to do any more. You know, well, that's it. I mean, that's all she's got, Captain. So let me see. The answer is the inductor windings are overcoupled. Yeah. The inductor's voltage rating is exceeded, causing a flashover. No, not saturation. Or D, the adjacent inductors become overcoupled. Well, you don't want to be coupling into the adjacent inductors anyway. If you do, you got poor design layout. So it's C, the ability of the inductor's core to store magnetic energy has been exceeded. That's what they're saying over in the chat room, except Andy. He guessed too much squeezium. I'm sorry, Andy. You could see where he could come up with that answer, though.
Does that make a good inductor core?
Squeezium, I don't think it's been tested yet for that. What is the primary cause of inductor self-resonance? A, inner turn capacitance.
B, the skin effect.
C, inductive kickback.
Or D, nonlinear core hysteresis, if that's how you pronounce that.
Close enough.
Hysteresis is how I would be
No,
tempted.
that's not it.
Primary cause of inductor self-resonance. Inner turn capacitance. I don't think it's the skin effect. And I've never heard of inductance kickback. That might be a thing, but I've never heard of it. Core, I don't even know what that is. So I'm going with A. Inner turn capacitance.
I'm going to agree with you along with everyone else in the chat room. Inner turn capacitance. And you know, here's the key on this one. They're talking about self-resonance. In other words, the inductor is resonant with itself. And we mentioned earlier that in a resonant circuit, typically you could have an inductor and a capacitor, and the two are resonant at a particular frequency. Mm-hmm. If you change either one, it's going to change that frequency. So if you got inductance and capacitance, you got a resonant circuit. So there.
Interesting.
Yeah. And that's all I got to say about that.
So that was the last of them, huh? For this
That
month.
for this month. That's all in section E6D.
Cool. Wasn't too bad.
No,
Even though
it
I
wasn't.
missed one of them. One of them was pretty nasty.
Yeah, fortunately that one fell on you, so it didn't affect me.
I was still saying that was rigged.
It wasn't. It really wasn't.
No, it doesn't matter anyway. I'll take one for the team. Don't matter.
Yeah. Well, that was a tough one.
Yeah, I had no clue. I didn't even see any way to reason that out.
Yeah. If you was thinking about the normal Lotus orbital tode method or whatever it was on the turbo entabulator, that's what it sounded like. I mean, it was just, yeah, kind of crazy.
Very much.
How many questions are left in the pool? I don't know, Arnie. Let's see. Yeah, we're about halfway through, Arnie.
Maybe a little more.
Maybe a little less. What do you think?
Oh. Yeah, actually it is a little less.
Yeah, there's other stuff in the back of the book here, though. So, if you strip all that out,
it's probably about halfway.
Yeah, about halfway. Yeah, this much.
So there's plenty more fun to go. Plenty more fun where that came from.
Yep. So I guess before we get out of here, we ought to mention a couple of things.
Like what?
Just two. Well, like for instance, what do you do every Tuesday night, Tommy? Except for this past Tuesday.
And maybe this coming Tuesday.
And maybe this coming one, yes.
Generally, I listen to the AmateurLogic sound check net. Not only do I listen, I actually check in on it. Sometimes it goes so far as to be one of the ones to call the net.
Net control operator.
Yeah. We have that every Tuesday night, as you can see, at 8 p.m. Central, 100 UTC. A lot of modes connected together. Pretty much all of the digital modes and some analog was connected through Echolink. We always have a question, and it keeps things kind of interesting. It's been a lot of fun.
And Arnie was asking in the chat room over there, when does the current pool expire? Well, Arnie, you've got 2 years and a month. Exactly. So this pool is aged about half, which is about where we are.
Yeah.
And if we see we're not going to make it in time, we'll start throwing some extras
Start doing
to
some extra
get
ones.
on through there. All right. One other thing we want to mention, and that is, if you just want to find out what's going on throughout the month, well, we have posts here and there on our Ham College Society and AmateurLogic. And actually, AmateurLogic's a little more active on that.
Mm-hmm.
Facebook.com/groups/HamCollege or /AmateurLogic.
Yeah. We're on Twitter also. Follow us at Ham College or at AmateurLogic.
MeWe.com/join/HamCollege or /AmateurLogic.
And we've got anti-social media, kind of. Not sure what you call it. It's more like a mail list, but we've got Groups.io. So Groups.io/G/AmateurLogic. And if you're not a Facebook or Twitter or MeWe person and you just want to get the notifications via email, that's the one that's for you.
Yeah, we only ever send out anything on there when we're letting you know about a live stream coming up, when a new show has been posted, or when there's going to be a net.
Yeah, that's generally it. There's not a lot of chit chat on there. Occasionally something here and there, but you won't get spammed from it.
Yeah, it's mostly just notifications. Hey, an event's coming up. And, you can help us out here. If you like Ham College or AmateurLogic, when you watch, click the like button and also share with your friends. Let them know about the shows. And we really appreciate it. It helps us out.
Oh, it definitely does. Yep. Comments are welcome as well.
Yeah. So we thank you for being here with us this month for another Ham College. We'll be back at the end of June for the next episode, and we'll be back around the middle of June for the next Amateur Logic. And that's going to be, what date will that be? Probably June the 17th. Sound about
either
right
the 10th
to you?
or the 17th.
10th or 17th.
So there you go.
Well, I know
subscribe to the social medias to get those.
Yeah. I know it won't be the 10th because I got something going on.
Well, then
that
it'll
day.
be the 17th then.
Okay.
So we'll see you then.
All right.
73, everybody.
7-3. Well, good evening, everyone. Welcome to another episode of Ham College. I'm Professor Thomas. What if I say that and come out
And when
behind
you
the dark screen?
Yeah, come out from behind the curtain.
We're still studying on the Amateur Logic. There's your blooper. So, next question. Let's see. Did I answer that one? Yes,
You
I
don't
did.
remember?
I think I did. What are we talking about?